In this video, we'll generate the trendline and trendline polynomials of the geometric series. Here we have a geometric series, which is x to the power alpha over 1 minus x. Our alpha will be data validation, list of items, 0, 1, 2, and 3. And our beta, so we begin with 0. Our alpha beta will be data validation, list of items, -1 or 1. So values of beta, -1 or 1. We start with -1. So this will be our formula of the x raised to the power alpha divided by the quantity 1 minus x. On the other side, you have our formula, x to the power alpha divided by the quantity 1 plus x. So this side is 1 plus x. So this is here, it's negative 0.5 or positive 0.555. This is 0.55. And this side is 5, this one is 5. And we generate the Taylor-Maclaurin series sum of both, where it is the summation of a times x to the power n plus alpha, where a is beta to the n and n is from 0 to infinity. So you can start from 0 to 16, which is a good enough approximation. And the value of a will be r from beta raised to the power n. Now we can calculate the series sum, which is equal to r formula, series sum of the x values raised to the power n plus alpha. N plus alpha starts from alpha, incremented by our n will be 0, 1, 2, 3, so it's incremented by 1. And the coefficient a will be this range. So if we change this to 1, this approximates the 1 minus x. If this beta is -1, you have 4.88, which approximates 5, and 0.568 approximates 0.55. And we'll chart this. Insert chart, and we'll use scatter chart. Use column A as label and show the trend line, polynomial to the 8th degree. Let's try the 10th degree if it works. No, it doesn't work. The 8th degree. And for the label, use the equation. For the legend, position at the bottom. We don't have a yellow in the data set, so we change the yellow to green. So this should be green to match our data set. And for the point size, maximum, except for the expansion, the point size will be none. But the line thickness will be maximum. And we don't need this portion, this title, because we need a space. So here's our trend line and polynomials of a geometric series. So we can toggle from -1 to +1. Right now at 1, so this approximates the x minus alpha of 1 minus x over 1 minus x to the power alpha. So at x is -1, beta is -1, the expansion approximates x to the power alpha over 1 plus x. We'll calculate this polynomial regression coefficients using LINEST. To do that, we complete the LINEST matrix, starting with the power, which is equal to transpose 0 to 8. And the elements of the matrix, which is equal to RA formula of the x values raised to the power 0 to 8. Enter. Now we can calculate like the polynomial regression coefficient LINEST, starting with the x over alpha over 1 minus x to the power alpha divided by 1 minus x, so data y, and this is our data x. The expansion, so LINEST, data y, and data x. And this would be data y, LINEST, data y, and data x. So starting from 0, so our coefficients would be 1, 1, 1, at x to the 0. Here, x, the coefficient of x, 0.992, negative 0.994, negative 0.992. This is just, the expansion is just an approximation. And x squared, 0.992, 0.994, 0.992. X cubed, that's 1.27, and this is negative 1.27, 1.20. X to the fourth, 1.27, 1.20, 1. That's x to the fourth, 1.20 and 1.27. X to the fifth, negative 1.08, 0.554, 1.08. X to the sixth, negative 1.08, negative 0.554, negative 1.08. X to the seventh, negative 5.38 or positive 5.38, 4.44, negative 5.38. And this is 5.38, 4.44, 5.38. You can toggle this to 1. The expansion approximates the x to the alpha over 1 minus x. The data sets here approximates this one. X to the negative 1, this data set approximates this, x to the alpha over 1 plus x. Likewise, their polynomial regression coefficient also approximates each other. We increase this to alpha equals 1. So here, negative 1, meaning the expansion approximates the x over alpha, x to the power alpha 1 plus x. We toggle this to positive 1. This time the expansion approximates the x to the power alpha over 1 minus x, just as their polynomial regression coefficients. And increase that to 2. You can toggle this to negative 1 or to positive 1. At x equals 3, can toggle this to -1 or +1. This completes the use of array formula, series sum, LINEST in the generation of the trend line and polynomials of the geometric series.